Hello everyone! So in this video, we're going to solve a word problem using differential equations with different topics. Catenary, the RL and RC circuits, and the Newton's second law of differential equation. So let's begin!
Good day everyone, I am Danmar Isisulat. Today we are going to solve planetary problems in application of the differential equation. So let's go!
So here is the problem. Ends of a rope having a certain weight are tied to a top of two different poles of height 4 meter and 12 meter such that it touches the ground, and the length of the rope between 2 points where it just touches the ground and the point of the top of the shorter pole is 8 meter. So we are tasked here to find the total length of the rope. So here is the figure. So we can see here the shorter pole is 4 meter and the higher one is 12 meter. So to find the total length of the rope, we are tasked here to solve the S. So to find the S, we are given the equation y is equals to the square root of c1 plus s squared plus c2. So our y here is 0 and it is equal to the c1 plus our s here is also 0 and plus the c2. So transposing the equation, negative square root of c1 is equals to the c2. So y is equals to the square root of c1 plus s squared minus c1 square root of c1 squared. So y plus c1 squared, transposing the negative square root of c1 here to the y so that it would be positive, and it's equal to the square root of c1 plus s squared. Next, y squared plus 2y squared times square root of c1 plus c1 is equals to c1 plus s squared. We can cancel here the c1 and the other one here so that it would be equal to y squared plus 2y times the square root of c1 is equals to the s squared. Next is to find the value of c. Here we can use y squared is equals to s squared plus c squared, and our y squared here is 4 plus c quantity squared is equals to the 8 squared plus c squared. So our c here, using our calculator, we can solve c is equals to 6. So y squared is equals to s squared plus 6 squared, plugging in the value, 12 plus 6 quantity squared is equals to s squared plus 6 squared. We can now solve our s here is equals to 12 square root of 2, and to solve the total length of the rope, it is equal to the 8 plus the 12 square root of 2 meter. That would be all. Thank you.
So today we are going to talk about application of first order differential equation in electrical circuits, RC circuits. I am Giancarlo Sales.
And I'm Lord Lawrence Gaines Legadona.
2. BSCPEB. In a series RC circuit, R is equals to 5 ohms, C is equals to 0.01 farad, and E is equals to 100 volts. When T is equals to 0 and I is equals to 0, find the charge at any time. For our equation, we write R dq over dt plus q over c is equals to E. Then we have to write the given 5 over dq over dt plus q, because we have done wala pa tayong q, all over c na 0.01 equals to E na 100 volts. Tapos i-divide natin both sides ng 5. So we can get dq over dt plus q over 5 multiplied by 0.01 is equals to 20. 5 multiplied by 0.01 will be 20q. So we have this dq over dt plus 20q is equals to 20. Then we can use a linear D in this situation. QE
20 integral with respect to dt is equals to integral 20a same as 20 dt with respect to t. Evaluate q a 20t is equals to 20 because this is a constant and this is a 20t and dt. We need to simply evaluate the integral of this. So we let u is equals to 20t, our du with respect to t is equals to 20 dt, and we need to accept somebody 20, so our du is equals to dt, du over 2 is equals to dt. We need to perform u substitution, a equals to u is equals to 20t, and our du is equals to du over 20. So we need to factor out 20 integral of eu du. 20 over 20 is 1 simply. QA 20t is equals to EU plus C. So we need to back substitute. QA 20t is equals to E. RU is 20t plus C. Expressing this in terms of purely Q, if we divide both sides by E20t and E20t plus C is equals to A20t. So we cancel this equals to 1. So plus C is equals to E20t. We need to apply the condition with E is equals to 0 and current is equals to 0. 0 is equals to 1 plus C, E20 times 0 is equals to 1. So the C is equals to negative 1. If we need to go back to this equation, we have Q is equals to 1, negative 1 equals to E20t, or you can evaluate this Q equals to 1 negative E raised to the power of negative
RL circuit. Then we have a problem, and inductance of L, Henry, and resistance of 10 ohms are connected in series with EMF of 100 volts if the current is initial 0 and is equal to 9 amperes after 1 second. So the given is E is to 100 volts, R is equal to 10 ohms. We look for L. So L, what you call this, the equation is L d over dt plus IR is equal to E. Then substitute L di over dt plus 10I is equal to 100 volts. We look we cancel this L, so 1 over L to cancel this L. Di over dt plus 10I over L is equal to 100 over L. Di over dt plus 10 over L times I is equal to 100 over L. Then we use linear. The linear formula is ye raised to integral of p of x dx is equal to integral of q of x e raised to p of x dx. Substitute I is equal to ie integral of 10 over L dt is equal to integral of 100 over L e integral of 10 over L dt. Then ie raised to 10 over L integral of dt is equal to 100 over L integral of e raised to 10 over L integral of dt. ie raised to 10 over L t is equal to 100 over L integral of e over 10 of e raised to 10 over L t dt. So we're gonna use let u in 10 over L. So let u 10 over L du is equal to 10 over L dt. dt is equal to L over 10 du. So next, I is equal ie 10 over L d is equal to 100 over L integral of eu times L over 10 du. ie 10 over L T is equal to 100 over L times L T EU du. Let's cancel this L. Then IE raised to 10 over LT is equal to 10 EU du. IE 10 over LT is equal to 10 E RL circuit. Then we have a problem, and inductance of L Henry and resistance of 10 ohms are connected in series with EMF of 100 volts if the current is initial 0 and is equal to 9 amperes after 1 second. So the given is E is to 100 volts, R is equal to 10 ohms. We look for L. So L, the what you call this, the equation is L d over dt plus IR is equal to E. Then substitute L raised to 10 over LT is equal is du. 10E raised to 10 over LT is du. 10E raised to 10 over LT du, i.e. 10 over L T is equal to 10E raised to 10 over L T plus C. Let's cancel the E over 10, so we get the I. Then I is equal to 10 E raised to 10 over LT over E raised to 10 over LT plus C over E raised to 10 over LT. So cancel this, then I is equal to 10 plus C over E raised to 10 over LT. Then we get the C. So to get the C, at T is equal to 0 and I is equal to 0. 0 is equal to 10 plus C over E 10 over L times 0. So the answer is C is equal to negative 10. Then next is to get the L. The equation is I is equal to 10 minus 10 over E 10 over LT at I is equal to 9 and at T is equal to 1. 9 minus 9 is equal to 10 minus 10 over E 10 over L 0. 9 is equal to 10 10 E raised to 10L. 9 is equal to 10 E raised to 10 over L minus 10 over E 10 over L. 9E raised to 10 over L is equal to 10E raised to 10 is equal to 10 over L minus 10. 9E 10 over L minus 10E 10 over L is equal to negative 10. Then negative E 10 over L is equal to negative 10. So let's times to negative become positive. Negative 1. Then positive E raised to 10 over L is equal to 10. Then we go to ln to cancel the E. So ln E raised to 10 over L is equal to ln 10. ln 10. 10 over L is equal to ln 10. So this, we can use calculator to solve this. Just shift calc to solve. Or this is the final answer. L is equal to 10 over ln 10 or 4.343. Thank you.
Hello everyone, I am Crisel E. Reyno. Our next problem is the application of differential equation in Newton's second law. So let's start. So here's the problem. A ball of mass of 2 kilograms is dropped from rest in a rescues fluid. So, okay, the resistance, which is 0.001 V Newton, where V is the instantaneous velocity in meter per second. What is the velocity in distance traveled with the ball after 4 seconds? So, okay, let's try. Let's write the given. The formula again is F plus M dV over dt. Okay, is equal to mg. So the resistive force is 0.001 V plus the mass 2 dV over dt is equals to 2 times 9.81. So again, we are going to divide both sides by 2. So it will be having dV over dt plus 0.001 over 2V is equal to 9.81. Okay, per 1 over 2, so magiging dV over t plus 1 over 2,000 V is equals to 9.81. So this is still again linear in V. So linear and V. So we're going to solve for V 1 over 2,000 dt is equals to 9.81 integral of E 1 over 2,000 dt, and so we have dt also here. So integrating factor VE 1 over 2,000 t is equals to 9.81 integral of E raised to 1 over 2,000 t. We have dt here. So if we integrate this, okay, I'm gonna let this and write first, okay. So if we integrate this, we will be having a correction factor of 2,000. So the reciprocal of 1 over 2,000 is 2,000. So 9.81 times 2,000. We copy the same e raised to t. Okay, we have, meron tayong t pala. Okay, so that should be t over 2,000 plus c. So we need to evaluate that. That is VE raised to t over 2,000 is equal to 9.81 times 2,000. So, ito magiging 19,620 raised to t over 2,000 plus c. So, divide both sides by the e raised to, so divide both sides, divide both sides by e 1 over t over 2,000. So, v raised to 19620 plus c over et over 2,000. And we need to solve for the value of c. So, there's no given condition that in the problem state that it is addressed, but let us assume that at time is equals to 0, velocity is equals to 0. So we need to find for the value of c. So this is 0 equals to 19620 plus c over e raised to 0 because our time is 0. So we simply equal to 1. So our c here is equals to negative 19620. So we can substitute it here. So 19620 minus 19620 over e raised to t over 2,000. So this will be our equation to find the velocity of the object at any time. So, but what is being asked is, what is the velocity and distance traveled by the ball after the seconds, 4 seconds. So, at time is equals to 4 seconds. What is V? So, V is equals to 19620 minus 19,620 over e raised to 4 over 2,000. And our answer should be 39.2 meter per second. So, we have answered the first question. Okay, how about the second question? What is the velocity after 4 seconds? And what is the distance traveled by the ball after 4 seconds? So, we know that our velocity at any time t is 19620 minus 19620 over e raised to t over 2,000. Okay. Distance, the relationship of the distance and velocity is that this velocity to change displacement at the time. So, v here is 19620 minus, I'm going to put this on our numerator. E negative. So, ipataas lang ito, kaya naging negative. So, our v equals to d over dt. So, we have dx over dt is equals to 19620 minus 19620 e raised to negative t. So cross multiply. So it will become dx over 19620 minus 19620 raised to t over 200. Ay, 2000 ay. Negative ito. So, wait. So we are going to integrate both sides. So we should get the distance. So we're going to integrate this with respect to t. So x equals to 19620 minus integral of 19620 e raised to negative t over 2000 dt. So upon integrating this integral, so x equals to 19620 times t minus 19620 e raised to. So we let u is equals to negative t over 2000. So we have du equals to negative 1 over 2000 dt. So as you can see, I would have a correction factor of negative 1 over 2000 in here in order for we to integrate the function. So negative 1 over 2000. So we're going we repeat it. 19620t minus 19620 multiplied by 2000, or I mean negative 2000. In order for us to integrate this, e is to u du. So we have x equals to 19620 multiplied by time. So 19620 multiplied by negative 2000. So we have negative here that becomes a positive value. Plus 3924 and 4 zeros. Okay. The integral of e raised to u. So our u would be negative 2 over 2000. So upon integration, we have the constant of integration, plus c. So we need to find, again, the value of c. Okay. So at time equals to 0, the distance traveled by the ball is equal to 0. Applying in our equation, so 19620 times 0 will become 0, plus 3924000 e raised to 0. 3924000 e raised to 0 plus c. So cancel this. The value of x also is 0. So 0 plus 3924000 plus c. So the value of c here is equals to negative 39244 zeros. So it will become x equals to 19620 plus 3924000 e raised to negative t over 2000 minus 39240. So I can factor out. So we have t here. So x will become 19620 t plus 39240 multiplied by e raised to negative t over 2000 minus 1. Okay. So this is the distance traveled with the object. And the problem is asking what is the distance traveled by the ball after 4 seconds. So meaning x should now be 19620 multiplied by the time, which is 4, plus 3924000 e raised to negative 4 over 2000 minus 1. So the total is 78.45 meters. So that should be our answer. And we must be careful and we must know how to solve linear equation and some integration or basic integration for us to solve this problem and fully understand.